welcome everyone. So it's a pleasure again being here with all of you with Mash. And I think I don't know how many sessions it's been, the fifth one or the sixth, I don't know.
I think it's fifth, yeah.
Fifth, yeah. So this is awesome.
Yeah, I think so.
Yeah, right? So this is awesome. So we're here to do today some TDD with Clojure, which is nice. I think it builds nice on top of the previous one that we wrote some tests, kind of tests.
Mhm.
And that's
Yeah.
it. So I'm facilitating, but who is running the session? My job is quote unquote easy, but the hard job is with Mash, because he's going to be sharing his screen, leading the talk. But if you have any questions or if you have any doubt, just put in the chat or open up your microphone and ask questions. And I think that's it. Mash, so I'll leave the floor for you.
Thank you, Matthias, and hello to everybody. Last time we did REPL-driven development, which was we tried a small kata in the REPL. It was the leap year kata, yeah. And today we are going to do the same kata, but using test-driven development. Clojure has a test library built in. There is another library called Mage. We're not going to be using that. The built-in library is enough. It can be it's just a different way of testing with Mage, but MIDJE if you need to know more about that. One of the prerequisites, if you want to follow along or type along rather, the prerequisite is that you have a IDE setup with tests. If you don't have it, don't worry. We're gonna do a bit for a kind of a mob session anyway. So you can either type along and do that, or you can, you can just shout out your suggestions or even put them on the chat if you don't feel like saying something. I'd like to kind of take you along this to introduce you to testing, first of all, in Clojure. And then we do the kata. And then I'll show you a little bit of how you can test functions with side effects as well, because in languages like Java and C#, you do that with mocks. So you try to isolate the unit under test from external calls and side effects. And you can do that with Clojure as well. And I'll show you that, a couple of techniques to do that as well. So without further ado, let's let me share my screen and then we get started, okay? So share screen, I will actually just share. Okay, so you can all see this? Yeah.
Yes, we can see. Just before you start, sorry to interrupt you. What is the name of the library that you said, the test library for Clojure?
The Clojure test library is actually built into Clojure core. It's a namespace called Clojure.test, yeah. And the other library that is outside is written by a guy I admire quite a lot. His name is Brian Merrick. He's one of the kind of all agile and software craftsmanship person. Comes from kind of Chicago, that area. So he wrote a library called Midge, MIDJE, Midge. Yeah, we won't be using that, but that's also quite an elegant library. But for all intents and purposes, Clojure Test will do everything you need as well. Yeah, it's just a matter of style. Midge has a slightly different style for testing. Okay, did that answer your question?
Yes, thank you.
All right, so the first thing is that if you don't have anything set up, when you do a line new, so we were using line previously, which is kind of like a build tool, line new, and you can name the project. And once you name the project, you basically get like this kind of structure. You get, this would be familiar to you. You get source and test, and then you can reflect the same namespace under those things. And then you have tests under test directory and your source code under source code directory. For the purposes of this, I'm going to put the source inside the test file as well. So just because then I'm not switching files all the time, which might lead you to confusion. So Generally, you have the core file where you would have your unit under test, your function under test in this case, and the core test file where you test the function, yeah? So in our case, we're just going to have the test file. This is all I will show you, right? And don't worry, it's the same as having the function located in the other place. And once you have the test, you can say line test, and it runs all the tests, right? At the moment, there are 0 tests containing 0 assertions, right? I have a Vim Fireplace with Vim setup, which is a Clojure plugin for Vim. But you can use Canva, you can use Visual Studio Code, you can use anything really. And you can even run the tests you can write the test in a file and just do line test every time you finish writing a test as well, fairly quick, as you can see. So that's also possible. So if you don't have an environment set up, just create a new project. And then every time you change the file, save the file and run line test, and it will do the same thing. Yeah. Okay. So all good. Right. So basically, the first thing is that, you in the test file, you require this, which basically means that all functions related to testing are then available to you in this namespace. And you don't have to import anything, create a new library, because actually this namespace is part of Clojure core, as I said earlier. Yeah. So let's write our first test. Actually, before I write first test, I'm gonna just run the REPL, because then that allows me to run my tests in within my Vim browser, right? So now that I have everything running, I can say def test, yeah. And remember, we had this say kind of hello function, yeah. So it's a say function, yeah. So we're going to test the say function. And remember, it's like the first thing I ever created, where I said, it's like say hello world or something, right? So in our case, the first thing that I'm going to, let's kind of start creating that. So it says, well, this is how you do it. So test, yeah, testing rather, says hello world, yeah. So now we can say is equals, let's say hello world, yeah. And then I can say my say function, yeah. And at the moment it takes nothing. So we're saying that when I call the say function, it returns hello world. That's what it's saying. And is basically a macro that kind of sits around it, so it gives me good error results. So now that I have the name of the function, of course, the function doesn't exist. So I can create this function called def say, yeah. Takes at the moment no arguments, yeah. Or in fact, this would be say hello, because that's what it is doing, right? So it's saying say hello. So now, so we can even call this say hello function. Okay. So now, if we don't return anything, which when you don't return anything, it returns null. In Clojure, something you should not nil, which is like and the last.
Sorry, Master, you're cutting off a little. Can you hear us?
Yeah. I thought it was me. Yeah. Thanks. Yeah.
Can you still hear me?
Yeah, we can hear you now.
Yeah.
You can. Okay. Sorry, just 1 second. I can't hear you that well now. Just 1 second. How about now? Can you hear me okay?
Yeah.
Yeah. Perfect. Okay. So it's just my mic that I had to take away. All right. So where was I? You heard me up until I was saying say hello, right? So I've created a function, say hello, and I've created the test as well. And the function will return nil or null. Yeah. So if now I can run this, yeah. And as you can see, okay, so it's actually failing to compile. Let me just see why that is. Okay. Say hello already refers to a namespace. Okay, so there is another function. So let me just remove that function. So from here, so sorry, just bear with me. So I'm going to remove this core namespace altogether because there is already a function that exists in another namespace, and that's why it's complaining. Okay. All right. So as you can see, when I did line test here at the bottom, it's saying that not hello world so it doesn't equal to nil, because basically what it's returning is nil. Yeah. So I'm going to do line REPL again. So I'm going to show you the same test being run in my in my IDE in Vim. So if I run this, as you can see at the bottom left, it's giving me the same problem. It's run one test and I'm getting a failure in the assertion. Okay. So now I can just return hello world. Yeah. Okay. And now when I run it, that's it, it's successful. Yeah. So as you can see at the bottom, it says it's a success. Okay. So this is basically how you write tests in Clojure. So now we can make this a bit even better. So let's say, well, we have another kind of test. So we say def test. This is a generic say function. Yeah. And what we're saying is that testing says the phrase corresponding to the keyword. Yeah. So in this case, what we're saying is equal hello world. If I now have a function called say, and then I say hello. Yeah. Okay. So now I have a new function that is, I'm saying is called say. It takes in a keyword and then it returns something. Yeah. So now when I run this, see, as says, okay. Now says the phrase corresponding to the word, the expected hello world when I say hello, but I'm getting nil. So again, in this case, I can use this. So just return hello world again. Yeah. And that will make my test pass. Okay. So that one is passing as well. So now what I can do is I can introduce another one. So in this case, I also want it to say, I don't know, I love Clojure. Yeah. When I say the keyword CLJ, no. Yeah. So let's try to run that again. As you can see, it's run those tests, but the I love Clojure part is not working. So now I can say, well, in this case, I can say if I can even say, well, or I can say case, let's say case, keyword. A keyword is actually a KV, is probably better. KV, if KV is so if KV is in our case So case KB, let's say, in this case, is Clojure love. Yeah. Then I would say I love Clojure. Yeah. And otherwise, I'm saying, in this case, otherwise I'm saying hello world. Right? Yeah. So I'm just gonna remove this and yeah. So that should work now. So I've got, so he's saying, well, if it's Clojure love, then do this, and then otherwise do this. You can do it with if statement as well, but I'll show you. In my case, probably better to kind of jump to this, right? So I have success. However, it's actually not correct, because if I say like something I don't know, yeah, so I can add another test. In this case, I can add another test to say, well, actually, I want to test something else as well. Testing says don't know, do not know when keyword is unknown. Yeah. So in this case, I'm saying is equals don't know. Yeah. When I say something, right? Because we know that something doesn't exist, it doesn't know something. Yeah. So now I can go like this and I say, all right, there you go. So say do not know when keyword is unknown, but actually when I pass in do not know, it's giving me hello world. So now I can fix that as well. And in our case, I can say, well, actually do that. So hello, like this. Yeah. So, and then the default is don't know. Yeah. Okay. So that kind of shows us how we go through, like you can start. One good thing I like about Clojure is you can have multiple assertions trying to test the same kind of behavior, right? So you can have like, you know, say something regarding a keyword, then you have all the examples within it. You have those assertions that are examples. And then when you're testing a different kind of behavior, you add that description, and then you test that kind of behavior. Yeah. It's just again, it's how you use these tests in Java or those languages. Often we say that, oh, don't include more than one assertion and that kind of stuff. But in Clojure and even in Java, actually, it's okay to include more than one assertion as long as you're testing the same kind of thing, and as long as the intent is the same. Yeah. Are people following me so far?
Yeah, I'm trying to follow you. I got the compilation error, but I'm trying to follow you along. I have one question though, because regarding this is, yeah, Sergey said that he's following along. This is awesome.
Cool.
There is, I understand that what you're referring to assertion is what you have, for example, in the line 23.
Yes. So line 23 is actually, so the assertion is, so basically this is in Clojure, well, these are macros, right? So there's a testing macro and it has this special form in there, which is called is. So you always have to include is, because what that allows you to do is then it knows how to generate the output if something passes or fails. And the actual assertion is this equal sign. And you can have other assertions as well. You can have not, or you can have bigger than, and those kind of things as well. Yeah. So this equal is the equality operator. You can, any comparison operator can exist there. Yeah. And then you have whatever the the operands of that operator are. In this case, equal has two operands, the left-hand side and the right-hand side. Yeah. But in Clojure, of course, the operator appears first and then all the operands. Yeah. So that's what it is, basically. All right. So actually, I'm just gonna get rid of this formatting markers so that they don't appear again. Okay. Yeah. So next thing we're gonna test is the we are going to do the leap year kata like we did before, but this time, how do we test the leap year kata? And before in the REPL, as you could, there are three let's say rules of leap year. Yeah, and we will. I'm just gonna copy and paste those rules here as well. This is by the way how you comment. Yeah. So is leap year if divisible by 4? Is leap year if divisible by 400, but not leap year if divisible by 100, but not 400, right? So the flow is very similar, right? Previously, we actually created, remember, we created leap years and not leap years and did a map in the REPL so I'll show you those two kind of things that we had. So we had all the leap years like this. So this is your test data in a way. So these are all the leap years or sample leap years, yeah. And not leap years. So these are not, the bottom ones are not leap years, the top ones are leap years, yeah. So now what you can do is you can do the same thing. You can say, well, I want to test leap years. So I say def test, yeah. So you can then def test a year, yeah. Then we can it's almost like it flows in the language, right? So now I'm testing. We can say so we can start with like the simplest thing, yeah. Is not a leap year, yeah. If not divisible. So for now we can just say it's not a leap year if not divisible by 4, yeah. Because so that's like we just kind of testing the negative first, as you want, right? So we can say, well, what is not divisible by 4? You can talk like say, what year is not divisible by 4?
Uh, 1995.
Yeah, so we have it in there. 1995 is not divisible by 4. So we say that it will return us false to say it's not a leap year. When I say leap, so in Clojure, sorry, my machine always, something goes wrong when I have Zoom running. My keyboard kind of freezes, so let it just come back. It's frozen. It's often when I share a screen in Zoom, I start getting this kind of behavior. Okay, not this back. Okay, so is false, and I can say, well, leap year like this, and I can give it a leap year like 1995. Yeah? So what it's saying is, okay, we're testing not a leap year, and then I can add a function here, which is the def n leap year, and take a year. And for now, I'm returning nothing. I'm going to make the test fail to make sure that everything is working. And you can see, like, leap year is not leap year if not visible, but it's failing because it's expecting false but getting a nil. Yeah. So in our case, we will just return false, yeah? Make the test pass. Okay, so that's working. Now we can add a few other things to kind of make it. So let's say the next one is like 1700. Yeah, 1700 is not, or something that I'm definitely sure is not divisible by 4. Let's say is, I don't know, 2. Yeah, or I don't know, 1997 is also not divisible by 4. Yeah, so let's do it. That's also false. So I can, all that will work as long as I keep giving it the false leap years. Excuse me. So now I can test the next thing, which is testing a year is leap year if divisible by 4. Yeah. So in this case, what I'm saying is that is equals true if I say leap year, and in this case, like 1996. Okay. And I can see that like I'm expecting true, but it's still false because I put false in there. What if I just be clever and then put true in there? See, now that one passed, but the other two that I already had failed. Yeah, so now I know that I have to start adding some other behavior in here. And in this case, I can just say, well, 0, remember? Mod year 4. I think that was it. Yeah, I think so. Let's see. Yeah, so I'm saying that, well, if it's divisible by 4 and the mod is 0, then yeah, that's what divisible by 4 means, right? Okay, so now I've got some more behavior going in. Yeah. Now, what's the next one? Is leap year if divisible? So what next thing is could be that is not leap year if divisible by 100, right? So now we can say, well, even if it's divisible by 4, but divisible 100, then it's not leap year, right? So now what we are saying here is let's go down. We are saying that it's 4, so there must be an and, yeah. So divisible by 4, yeah, and we're saying it's not divisible by 100, yeah. So which one would that be? So something that is divisible by 4, but also divisible by 100 is not a leap year. So I think 1800, yeah, it's divisible by 100. And is it divisible by 4? 1800? Yeah, it is divisible by 4. But because it's also divisible by 100, it's actually not a leap year. Yeah. Okay. So sorry, I did a bad thing there. What was the bad thing I did? Don't know. I wrote the code before the test. You should be checking. So let's go back. Okay. Now let's do a test again. I said it, but I didn't write it. Right. Testing is not leap year if divisible by 4. Well, we're just saying if divisible by 100, right? Regardless of if it's divisible by 4 or not. So what we're saying here is if it's divisible by, so we can now go back and decide this. And we just talked about 1800. Yeah. And we're saying that this should be false. Yeah. So it's actually getting a true. So we now know that our code is wrong. And so let's go back and fix our code so that it does what we need it to do. So then now we start adding and, yeah. So the first one is that, and then also 0 mod here 100. Yeah, okay. So now is leap year is divisible by 4, but the other ones are failing as well, and they should not be failing, right? So this actually maybe is a. So how would you do that, right? So if it's 4, it's a leap year, but if it's 4 and 100, then it's not a leap year. Yeah. So you could actually just be really like this. So you can say or, yeah. So if it's 4, oh yeah, sorry, that's why it's not failing, because it should be not. Yeah. All right. So now this should pass. Yeah. So now we're saying that it's divisible by 4 and not divisible by 100, then it's a leap year. Yeah. There is the final thing, which was this final bit of knowledge that we have, is that it's not leap year if divisible by 100, but not 400. Yeah. So now you can see, for example, 2400 is actually divisible by 100 as well, but it's actually also divisible by 400, which means that it makes it a leap year, right? But if we add that now, the last one, testing is leap year, yeah. In this case, so I'm kind of saying it in a different way. Is leap year if divisible by 4 and 400. Yeah. So in this case, I can just copy this. But what I'm saying is that this should be true. And it should be 400. Yeah. And lo and behold, that's wrong, right? So now what we can do is we need to change our logic so that that also works. Yeah. Okay. So let's change the logic. So now we're saying that we have to do a 400 as well. So one thing we know for a fact is that if it's divisible by 400, it's definitely divisible by 4 anyway. So what we can do is we can start making that a bit better. So we can say, well, actually, it's an or. It should be 0 mod here 400. Yeah. And then we can bring the and part in there as well. Yeah, divisible by 4 and divisible by 1. So it's either that or the other one that we already have. Yeah. Just format that a bit better. Okay. That should be. Yeah. All that has passed. Make sense? So this is a TDD flow in Clojure. Any comments? I'm just going to look into chat as well, just to make sure that everyone's. Okay. Yeah, cool. So any questions, any comments?
Let's see if we have anyone in the chat. If not, I have a question.
Yeah, maybe can you show some more complicated example? Like, do you have any tests from your real application when you are testing something more complicated than simple statements?
Yeah, it's a good question. Let me see. Okay, so I can show you. Maybe I can't remember if it's Mage or well, we have one of our internal exam application, and that uses Mage. I can show you that. What else can I show you? Yeah, let me. I think that uses Mage. Let me just. It's been. I haven't looked at that code base for a while, so this is kind of unplanned part of the thing. So, but let me see if I can. So just bear with me. So I'm gonna have a quick look. Actually, while you're here, you can look with me. Yeah. So. Okay, so this is maybe worth looking into because this is a real world web application written in Clojure. Yeah. So as you can see, it's got a bunch of tests. Yeah. And at here, the way that we are testing certain aspects, I think we're using Mage. So it's going to take to come on. Yeah. So in this case, it's using Mage, but it's a very similar idea. In Mage, the way that it describes things is a fact, and Mage is much better at using doing mocking and these kind of things. I will show you mocking in Clojure test as well, but Mage is better. By the way, do I have 20 minutes left? How long do I have left?
Yeah, around 20 minutes.
Around 20. Okay, thank you. So the way it works is that Mage is slightly different. We don't use the is thing. We use a slightly different mechanism where, so here I'm saying, okay, my activities controller, delete activity. When I pass a kind of activity ID, so by the way, this activity ID doesn't even exist. I'm just saying a kind of activity ID. Then I get 1, which is the number of entities deleted, provided, and this is the mocking part, that the model, when it asks the model on has entries for that activity ID, I say there aren't any. So, and that the delete on the model is called 1 and the 1 is returned. So what it's saying is that this activity, delete this activity, if it doesn't have any associated entries, yeah, and that I'm testing, this is an interaction test, yeah, that the delete activity was called 1 time. So Mage is better at doing these interaction tests, yeah, which often you find in other testing libraries. And similarly here is saying, okay, it does not delete an activity if it has associated time entries. And then here is saying, if I call delete entity with activity ID, it will give me a bad operation, and provided that when the activity has entries called with that same activity ID, it says, yes, it does have activities. And the delete operation is called 0 times. So it's saying that there is no delete called because it's this activity cannot be deleted. Yeah. So that's an example. I'll show you another example. So for example, in allowance entries, so this is a much, so here I have set up data, and I am saying like calculate the number of days taken from an allowance, and saying, okay, if I have this summary and I call it with this, given that the data that I have, then I have this summary, which is basically provided that the time is this and the allocated allowances are the allowances that I have provided. These are the allowances, yeah, and the time entries are these. So this is is probably the most complex test I have ever written, but I thought I'll show you because this actually, in order to do this in Java, would be like massive. But what it's doing here is saying, given all, is testing this function that does kind of taking all this data, combining with this data, gives you a summary of that data. It pivots the data and does a lot of those things internally. But externally, what I'm saying is that given this above data, when I ask for the summary, I get this. Yeah. And that's basically from line 9 to line 31. So that's 20 lines. In Java, that would be a hell of a lot of lines of code. But it's the most complex array. It's basically a report. So I'm testing a whole report based on that. Yeah. So this is again a way of testing. There are tests using specs and those kind of things as well, but I won't go into that. If you have to really do kind of complex interaction-based testing, then you can use Mage is better for interaction. But you don't have to. You can actually do the same thing that I'm doing here with Clojure test as well. It's just that this one, to me, it kind of flows a bit better in this case. That's why I chose it. But that leads me to, by the way, does that show you kind of a bit more of an example of something that's a bit heavy? Yeah.
Yeah. Thank you for presentation.
Oh, back to the test that we had here. You can test things that have side effects. So let me just show you. Let's say that we have a function that has a side effect. So I'm going to create the function first in this case, just to kind of illustrate. Yeah. So let's say that this function is about, it's about logging. Yeah. I can even bring that in. Yeah. So the way this function works is it says, okay, defn log side effect, let's just call it. And it takes in, let's say, well, let's call it level, log level. Yeah. And it takes in a level and a message. Yeah. And then it prints that level and the message together. Yeah. So this is how you would do that. Level and message. So it's like it concatenates the level and the message with a colon and a space. Yeah. Right. So now when I say, I can say test, def test. Yeah. Def test. Okay. And I can say, well, this is a test which is testing, let's say, logging. And I'm saying is testing level and message are concatenated. Yeah. Are displayed together, or let's say. Yeah. And then I can say, well, now is equal. What I really want for this thing to do is to so if I say, let's say the level is error. Yeah. So it should print like this, error, then colon, and then let's say messages exception occurred. Yeah. Okay. So that's what I am expecting back for it to print. And I call log level with the level error and the message to be exception. Yeah. Okay. Okay. When I test this, This should not be dev test login. Is that successful? Sorry, just bear with me. Successful. Like that. Okay.
Even, even if you change the message,
So I say log level, and it should do a print ln. Yeah. It's providing level and error. Okay. Maybe it's already a method there. Let's just log in. Oh, that's fine. Maybe. Let me say log. Yeah. Okay. So well, yeah, so it's a function that already existed in my namespace because I was working on that before. So basically what it's saying is it's got null back and I'm expecting exception occurred, right? Because of course, what the println has a side effect. It's actually a function that just prints to screen. So it's not returning anything. Yeah. So this is a side effect and I can't test it without a mock, basically. Well, in Clojure, there is a way of doing mocks. As I showed you in Make, there is like using this provided macro, but actually it has, Clojure has this thing called with redefs. Yeah. And then with redefs, what you can do is you can say, you can provide a alternative for that function. So I'm saying println, redefine println, and it's a function that takes in a message and it just returns that message to me. Yeah. So, and then I'm including the testing inside the scope of that with redef. Yeah. So it will only redefine this function within the scope of my test and not otherwise. Yeah. And then if I do this, then not an assertion. Function. Wrong number of arguments passed. Oh yes, sorry. So it's because I have it. So now with redefs, sorry, just 1 second.
so you're saying that it's the message that is different.
Right.
The
The
next
with
exception.
redefs only works with this. So you can say kind of with redefs and give it the name of the function, and then you can call that function and it should run fine.
Yeah, like with redefs, the println is in the vector, and the body of the function that return message, the vector might be this is the wrong place.
Sorry,
because
can you say that again?
with redefs, yeah, you have open the vector, and then in the vector you place the body that return the message, and error is wrong number of arguments. So maybe this is the place.
Yeah, it's like println is being called. So I'm redefining println here. And it's saying it's got 2. And when I say log with those 2, wrong number of arguments passed to that function. So it seems like it's calling the log somehow rather than the println, which is a bit weird. So log.
Sorry,
This
in
should-
the log, you have exception occurred with only one C, but in the test,
there
you
you
have
go.
with
There you
two
go.
C.
There you go. There you go.
There you go.
Yeah, the redirect function has a very bad. Yeah, there you go. Thank you. It has very bad error reporting. That's one problem with it. There is another way, so that works now. So as you can see, I've kind of changed the function that does the side effect to just return, give me the message that was passed to it, so that I can assert what the message is. Yeah. So now, with the other way to do this kind of thing is what's known as, like, I think in JavaScript they call it a thunk, where you move the side effect out of the function. So what you can, for example, do is rather than having kind of redefs, you can actually say, well, and I'm not going to return. So you create like a wrapper around the function. So you say, well, log function is going to be a pure function. Yeah. So I can call this another function called log pure that takes a level and message. Yeah. So this is kind of moving pure and impure things, right? And then you can say, well, okay, what it does, rather than calling the function, it returns the function it will call and the message that it will call it with. Yeah. Okay. So rather than actually calling the println, it's just going to give me the recipe back. So then I can, for example, in this case, remove it out of the with redefs, yeah. Okay. And then, of course, then I say, well, log pure. Yeah. But this won't work, of course, but we can make it fail first. Yeah. So syntax error, compiling. Yeah. So this is yeah. So it actually should just say, let me just try to test that. Sometimes the errors matter out of this. And it was also in string in this context. So, oh yes, sorry, my bad. str. So like this. So this is going to, if I run that test again. So as you can see on the bottom right, it's expecting exception occurred, but it's getting this object with something exception occurred back. And then what I can do here, so it'll be the same here now. Let me just do the REPL again. So now if I run this again, yeah. So I get this error back. Yeah. Now what I can do in here is I can do like a let. In let, I can say function and I can say the message, yeah. And now I can call my function, my pure function here, yeah. Yeah. And now I can say, well, okay, the message was this. So what I'm doing here is making pure functions. Just let me see why that's failing. Testing level the message together. Pure function. And is, oh yes, my bad. So within the let is like I showed you last time. It's based one of the previous lessons. We went through let. It's basically like a local variable. So I'm saying call log pure and store the values that you get, which is basically a tuple with two values. The first value is call function. The second one message. And now I'm just going to test the message that was returned. Yeah. And if I do that, it passes. Yeah. So this is a way of removing side effects out of the functions. Yeah. And what you can now do is you can refactor your actual side effect one and you can just say, you can do the same thing here. So you can say, you can have this let thing that I have here. So you can say let function message, yeah. And now you can call that, call the, oops, sorry, call the log pure in there. Yeah. And then that, and pass in the level and the message, yeah. So, and then within this let, what you can do is now you can call function and pass in the message. So this is just becomes like a scaffolding that you don't test, because this is the bit that all it's doing is passing to the log pure function, but then whatever it returns, it's executing it, right? So you don't need to test it. So you move side effects to the outside your pure functions, yeah? And then all you need to test is the pure function that is doing the actual logic. Yeah. So in functional languages, this is what happens. Your core is pure function side effect free, and on the outside you have code that is not unit tested, but maybe tested with your acceptance tests that has the side effects. So in Haskell, you do this all the time with monads and those kind of things. In Clojure, you can also do it with basically kind of passing the side effect part out of the function and then testing it. Yeah. Does that make sense? Yeah. It doesn't to you. What
Too much,
part
is
doesn't
that
make sense?
too much is really advanced to me. I mean, because I understand the part of a pure and impure, but I lost the understanding, because for me, you're just calling the same function, but wrapping them in a different level.
Yeah, so basically, think of this bit, you know, the str bit, yeah? Think of this part is the actual behavior. Yeah. Where it's doing a string concatenation. Line 75 is the actual behavior of the log function, right? And the other part is that it uses, once it's concatenated the string, it will call it with this println function. Yeah. So what it does is it sends, it's almost like, you know, like you get these recipe books with all the ingredients prepared and all you do is put it in the oven. Yeah. So it's saying, okay, I'm not testing the bit that is put in the oven. I'm testing all the recipes created correctly with the right amount and everything else. So you got these two functions now. The log function is the unpure function that you don't test. Yeah. But all that does is it calls the pure function. Whatever it gets back, it just applies the function to the parameters that it got. So it's a very dumb function, 68. Yeah. But it's that's the thing. Normally the call part is quite dumb. So I'm not going to test this function because it's a dumb thing. And it is the thing that is doing what I do need to know is which function gets called and what parameters get passed at the boundary. Yeah. So then what I've done here is in 73, I have taken the logic from the log function that really need to be tested and the function that will be called from that using the results of that logic. And now I can pull those out and I can test the pure function without any side effects. But I'm not testing the function 68 because all that does is it takes the function that pure function gives it and the parameters that it gives it and it just calls it. So it's just a call. So I know which function is being called and I know what is being called with, and that's all I need to test. So if you really think about it, when you do mocking in Java and so on, and you do this interaction testing, you say this function was called with these parameters. It's basically exactly the same.
Good.
But in functional way.
In function.
Oh, yeah, exactly. I'm using higher order functions. I'm passing a function out that then gets applied.
Okay. Interesting. Well, thank you.
But in JavaScript, this is used a lot, by the way, this technique, because, and it's known as a tongue in JavaScript. But in any functional languages or any language where you have higher order functions, you can do that. And that allows you to separate the logic, the side effect logic away from your otherwise pure function.
Awesome.
Cool. All right. So this is testing 101 in Clojure.
Well, I cannot like think about like, I don't know, 101, 202. If this is 101, wow. Okay, so I think that's it. I don't know, Valerie, if you want, wow.
Yeah. I mean,
up.
I wanted to thank you, Mash and Software Crafters Madrid, for organizing and executing this circuit about Clojure. And I wanted to remind everyone, of course, that all of these videos, all of the past sessions are on our YouTube channel. So if you ever want to check them out to clarify any doubts, or you could also leave us some comments on our YouTube channel if you have any further questions. And thank you so much, everyone, for joining us for the past couple of months.
It's been a real pleasure for me as well to run through this again. As you can imagine, I don't get to code a lot in my day job these days. So just getting the opportunity to do it a bit is pleasurable.